I think we're going to like this problem. Part A just says find the slope of the tangent line. So that's just going to be your derivative, right? And so remember, if you have a constant on the top, you can move that whole stuff up to the top, rewrite it like that to the -1, then multiply by the power of the inside alone, decrease the power by 1, times it by the derivative of the inside, get rid of your negative exponents, and then just be real careful because there's no calculator on this one. You got to plug in that x equals 3 right there, get the slope of that tangent line. Now, if it says the equation of the tangent line, then you need to do the point slope form. So at this point, I know the x value. I would have to plug that back into the original to figure out the y value and then do my point slope form. But if it just says find the slope of the curve or slope of the tangent line, you just need to do the derivative. Careful with that arithmetic. So you'll find the derivative. They asked for that. And they said find the slope. Actually just said find the slope of that tangent line right there. So that's what they're asking for right there, right? But you got to get that derivative to find that. Letter B says find each point, find the x coordinate for each critical point. Critical point, remember, that's where the derivative is equal to 0. And then once you find that derivative set equal to 0, then we got to classify it as a relative max, relative min, or neither. So I'm going to take the first derivative, set it equal to 0. This is my first derivative. Remember, a fraction is equal to 0, where the top is equal to 0. So that's going to be the x equals 7/4. So they asked for that first. Find the critical number. That's just where it's equal to 0. Now remember, just because the derivative is equal to 0 there, that's a possible max or min. That doesn't guarantee it's going to be a max or min. You got to check to see if that derivative switches sign on either side of it. So I'm just going to make like an x, y prime chart because I don't really care about the y variable here. But so I just put that on my x, y prime chart. That's where the derivative is equal to 0. So remember, we're going to do like what we did a long time ago when checking for max and mins. You're going to check something to the left and to the right of that. So you could choose 0, you could choose 1, and I'm just plugging it into this first derivative right there. I'm trying to determine whether the first derivative is positive or negative. And then I notice that that bottom part right there is squared. So that part is always positive. So then I really just got to plug it into the numerator. So I plug in 1 right there. I got 4 minus 7. That's a -3 times -3. Negative times negative is going to give me a positive. When I take 2 and plug it in, I get 8 minus 7, which is positive times a negative. That's going to give me a negative. And since my first derivative switches from positive to negative, that means my function went from increasing to decreasing. And so that means there's going to be a relative max there since my f prime changed from plus to minus. You can't just have the chart and then say there's going to be a max, or you have to say this little phrase. That's your justification. You got to tell me why you knew it was a maximum versus a minimum. And that's because your f prime changed from plus to minus. So just make sure you justify that properly. Letter C and D. C gives you a fraction, and it already did the partial fractions for you. That was nice of them. It didn't have to do that. They could have said integrate this thing somehow, or you see this, you see the integral symbol, means you're going to integrate it. And if you can factor that denominator, that's when you're allowed to use partial fractions. But they already did the partial fractions for us. So they put like A over this, B over this, and then they found the A and the B. So that was super nice. And then it just says evaluate the integral or show that the integral diverges. This is just your integral test. We're either going to get an answer for it, and that's going to converge, or you're going to get like infinity for it, and then that's going to diverge. So you remember when you do the improper integral, you got to be careful with the notation on the free response part of this AP test. So you got to replace that infinity with a b, do the limits that b approaches infinity, and then you have your stuff there that they told you to integrate. Now, when we integrate this guy, that's just the ln of x minus 1. But when you integrate here, this 2 pops out. Then you got 1 over 2x minus 5. Remember, that's going to be the ln of that 2x minus 5, but technically your d was equal to the 2x minus 5. Your u is equal to the 2x minus 5. Your d was equal to 2. So you got to balance that 2 with the extra 1/2. So do it in your head, whatever, write it down, the u to u steps if you need to, but just make sure you pull that 2 out, you balance that extra 2 with the 1/2, those cancel out. So this is what we're left with here. Evaluate that from 5 to b. So plug in the top number, plug in the b, minus, and then take the 5, plug in the 5. And then I was just kind of condensing some things here because I was supposed to do a limit as b approaches infinity, and I didn't want to have infinity minus infinity. So I used my pre-calc properties and merge those together, and then this is as you approach infinity. Remember, this is like 2b over b. Those degrees are the same, so that answer is going to go to 2. And then so you just got this ln of 2 minus ln of 5/4 right there. Now, if it ever gets a little bit tricky, you kind of stop or whatever, but this is just basic pre-calc properties where you're going to divide the two things. Remember, the log of a minus log of b is log of a divided by b. So you just divide those two things, and when I have, that's like 2 over 1 divided by 5/4. So that means I'm going to times it by the reciprocal to get that ln of 8 over 5 right there. Now it just says evaluate it or show that it diverges. So if I would have gotten infinity for this, then I would just put diverge and then all my work there with the proper notation, everything, showing how I'm getting infinity. But it just says evaluate that, so that's all I do. It didn't really say state converge or diverge, but you could put converge down, but that it just says evaluate that, so get the answer. And then the last part, it says determine whether this series converges or diverges, and this is just like all of our chapter 9 converge diverge tests there. We're just going to determine whether it converges or diverges. Now, technically, right here, you already did this. You could just say, hey, the integral test, I show that this converges right there. Okay, so I mean that's good. But technically, to use the integral test, you might want to mention, hey, we got a continuous function, we got positive terms, something's decreasing. There's little stipulations. Use the integral test. I think we'll be happy too. When we did this in the past, we used just a limit comparison test on this one. That's what the route I would have gone. And in that way, if you mess something up on this one, then you know how to do an easy limit comparison test on this one here. And that was kind of recently added to the AP test there. So remember your comparison test, they'll use the 1 over n squared as your comparison series. That's a convergent P series. And then remember, you're going to do limit as n approaches infinity of the original series divided by the comparison one. And that means we're going to multiply by the reciprocal. And I get the same degrees on the top and the bottom. So now I'm going to get that 3 over 2. And then remember what you're looking for. You're looking for a finite positive number. Since I did get a finite positive number, that means both series are going to do the same thing. So since this one converged, this original one will also converge. And then our limit comparison test. And notice it just says the same stuff. It says state the conditions of the test used for determining converge diverge. That's how we just had you practicing in the past. We say converge or diverge, and then you tell me the test that you're using right there. Soccer.